Good morning, everyone. Last week, I had the chance to go on a fully autonomous car on the streets of Paris. And it was actually really cool. The car sped up, it slowed down. We actually passed other cars. We saw a traffic light. We came to a stop. We turned at an intersection. And then we were driving along and we came to a narrow road. And there were two cars double parked at that narrow road. And there was a guy, probably something had gone wrong, smoking a cigarette standing on the street next to them. Well, the autonomous car didn't know what to do, so the driver had to take over. It's this type of problem that is going to plague driverless cars for years to come. But fortunately, mass transit isn't nearly so chaotic. And I believe and I expect that we're going to see AI-enhanced features and autonomous trains sooner than you expect. In fact, I bet that we will see autonomous mass transit before we see driverless cars on the road. Now you might say, what's the difference? We have driverless Cb Tc, and we've had it for a long time. And that's true. I used to have blonde hair and no wrinkles at one point, and my friend over there had quite a bit of hair when the first system went into revenue. And those systems are safety integrity level 4. So what's the difference and why will it be better? Well, the reason is the concept of autonomy versus automatic systems. So you see, today, Cb Tc is automatic. And automatic means that they're programmed according to a set of rules and they follow those rules. Trains actually are blind, they don't sense their surroundings, and they rely upon continuous communication with wayside computers to allow them to proceed. So if something happens that is outside of the programming parameters, human intervention is required. And obviously in a driverless system, that's a problem. For example, in a driverless Cb Tc, if we lose communications, what happens? Well, all the trains come to a stop, regardless of their location. And you can imagine in the summer, on a hot summer day with all those angry people crammed into all those subway cars, what happens? In contrast, an autonomous train will sense its surroundings and safely proceed to the next station with its passengers, even in the event of loss of communication. And that's a key difference. So an autonomous train senses its surroundings. And it senses its surroundings using sensors such as LiDARs, cameras, and radars, along with computer vision software to detect patterns in the environment and react to them. So an autonomous train can respond and react independently. So, as another example, what would you do today in the event of having a big event, like a concert or a big game in your city at the control center? Well, you might adjust the timetables manually to deal with the people. In autonomous mass transit, the control center will also have autonomous functions. And it will respond, it will interact with other systems and with passengers to optimize their travel. And so finally, what about maintenance systems? Well, maintenance systems will use all of that data, the sensor data that they're getting from the trains, to give you new insights about your transit system. They can monitor ride comfort. They could look at whether there's water seepage in the tunnels and much more. So, is Cb Tc obsolete? The answer is no, it isn't obsolete, but it will be a lot better. So autonomy brings a lot of added benefit to Cb Tc, but we still need communications and wayside computers to coordinate the movements of all those trains through the system. So what are some of the challenges that we still need to face? Well, computer vision artificial intelligence and sensor fusion algorithms require very powerful computers. And those powerful computers require a lot of energy, and they generate a lot of heat. That may not be an issue in a control center, but it is an issue in a train. Well, maybe not for Stockholm in the winter, where you may want the heat, but otherwise, it's a problem. But fortunately, thanks to the car industry, efficient high-performance processors are on the way, and we should have a solution in the next 1 to 2 years. Now, to get all of that sensor data, and there's a lot, by the way, to get the sensor data off the trains, we need high-performance wireless networks, and we need to be able to process that data. Well, networks like 5G are coming, and they should provide cyber-secured data transport to get the information off the trains. And AI-based data mining should allow us, in fact, it will allow us to mine the sensor data and get useful insights both for operations and for maintenance. Now, achieving SIL 4 is actually very tough, especially for AI-based systems. Now, safety integrity level 4 means no more than one hazardous event per 114,000 years of revenue service. It's a long time. It's like saying we've had a perfect safety record since the start of the Stone Age. So it gives you some idea of the challenge. Well, eventually, we are going to need to integrate artificial intelligence into critical functions. But before we can do that, the output of AI needs to be explainable. And that's actually a hot research topic. So it is being worked on, but until we get there, we can actually still do a lot for artificial intelligence. So in conclusion, autonomous transit is coming, and it's coming faster than you expect. It'll be there before driverless cars are on the road. So imagine trains that sense their surroundings, control centers that interact with other systems and with passengers, and maintenance systems that literally see problems. So autonomy isn't an end in itself, it's a new beginning. So you need to ask yourself, what am I going to do with autonomy? And ask yourself, am I ready for the future? Thank you.